Hi, today we will take a look on this very vintage instrument. So this is an amplifier Compass Servo, it is written here. This is another Compass coupler actually. This device permits to synchronize a gyro using a flux detector. The flux detector is something like that. I have one here. Therefore there are two inputs on this kind of instruments. The first one is a compass transmitter, and the second input is a directional gyro, which is here, and the output should be a synchro. There are several test points here, and we can see here on the left something which permits the adjustment . There are several screws. It is something we have already seen in a previous Bendix compass coupler also. We have here the indication of the heading and the correction which is applied using these little screws here. First, let's open this thing to see what is inside. Okay, look at that. We have some vacuum tubes. We have 3 electronic modules. And we have on the top here an electromechanical device. This thing is sealed. And there is a large connector. And we can see also a bunch of relays. There is 1, 2, 3, 4, 5, 6, 7 relays here. The most interesting thing is of course the electromechanical device, this assembly here. Okay, so first let's have a look on the electronic modules. Okay, so this is the first one. Okay, so there is a transformer here. And there are 2 vacuum tubes. Okay, so the reference is written 6AK6. Okay, so this seems to be a single pentode. Oh, there is another miniature tube here. And a few passive parts, capacitor, resistors. So I don't know what is the function of this module. It is maybe a magnetic amplifier for the servo control, but I don't know. This transformer doesn't have the typical look of the saturable reactor. Okay, so let's see the second module. Okay, so this seems to be the power supply. So we have a rectifying bridge here with 4 diodes. And there is an OB2. So this is a voltage regulator. And there is one big transformer here for the power supply, and another one. I didn't see, but there is another module here, a small one, vertically orientated. Okay, so this is the third module. So there are 2 vacuum tubes. Okay, so this one is a dual triode from Sylvania. The second one is the same. And there is one transformer, I think it is a transformer, and a few passive parts. And this thing seems to be also a transformer. And there is an adjustment. Let's have a look on the last electronic module, this one here. Okay, so there are a few passive parts on that side. And on the other side there is a transformer. I think it's a transformer, but it is not obvious. Yeah, we can see a few diodes and some capacitors. And this thing is not heavy. It is maybe a potted module. And there is a part here, so this is maybe a transformer, this cylinder stuff. This is the relay assembly. You can see the reference of the relays. Now this is the electromechanical assembly. I need to remove all these screws. Look at that. Look at this big synchro transmitter, quite impressive. Well, this thing is also a synchro transmitter, smaller one. This is another synchro transmitter, probably. There is something quite weird here. Okay, so this is a solenoid. This is a kind of clutch. So I think this is a synchro with a clutch here, but it seems that there is another clutch here. Oh, I don't know exactly. And we have here the motor generator for the servo control. And we have another thing here. So it is difficult to read. So I think this is an electrical gearbox. There is one shaft here on that side and another one on the other side. So you can see that there are only two wires connected to that device, and I can read here speed change and maybe high speed change. This is maybe a gearbox. You can see the voltage of the coil, 28 volts probably. The size of that synchro is incredible. The diameter is 55 millimeters, approximately 2 inches. The length a little bit more, 6 centimeters. Okay, so this is a transmitter. We can see the mechanism which permits to adjust the output. There is a roller here, you can see it, which is attached to this lever. The deformation of the plate permits to have a small rotation of the shaft depending on the screws, and the variation of the angle of this helicoidal gear is transmitted to the output shaft. So there is one input shaft, which is this one here. Okay, so this gear is linked to this one, which is the input of the device, and the output is here. This is this shaft here. The difference between the input shaft, which is here, okay, and the output shaft depends on the configuration of the screws here. I think we have something close to the Bendix compass coupler. On this one, you can see the video number 287. This is the block diagram of the previous compass coupler. Okay, we can see the output shaft here. We can see the correction, which is performed by this motor. And there is a gearbox which permits to select between the fast mode and the normal mode. The fast mode permits to synchronize the gyro at the beginning of the flight, and after that the normal mode is used. In that case, there is a large reduction here, which permits to have a very slow integration of the correction, and the result actually is added to the output. On that system, a differential synchro is used. Okay, so we can see on that system this motor, and here this electrical gearbox. So it seems obvious that this motor is a correction motor. Okay, so this gearbox permits to select between the normal mode and the fast mode. But I didn't see any differential synchro, so probably a differential gear is used, but it is not visible. There are some gears which are deep inside, so it is difficult to see. Okay, I will use this endoscope in order to see if we can find this differential gear. Oh, look at that. We have a differential gear. Okay, we can see that the correction motor here is linked to one input of the differential gear. Okay, so I have tested the 3 pins of this connector here. The compass transmitter are connected to that device. Okay, so this is the control transformer. It is specified for 400 Hz, but normally the signals are at 800 Hz. Okay, so this is the control transformer for the flux detector. We can see also that the rotor is connected to that connector here, this pin. Therefore, this module is a slaving amplifier. Okay, so the slaving amplifier is that module here. Okay, we can see the input here. It is effectively a shunted cable. Okay, so generally there is a capacitor in parallel to the rotor in order to tune the synchro transformer to 800 Hz. So this is maybe this capacitor. Okay, bingo. So this capacitor is connected in parallel to the rotor of the control transformer. So this is the tuning capacitor. We can see also that 2 wires of this motor here are connected together on that point here. The green and the black-red wires. And this is probably a motor with 2 control windings, and they are connected actually in series. And there is something interesting. If we measure the resistance between this point and this connector here, we find that there is a resistance of 220 ohms here and 220 ohms also on that point, and 460 ohms approximately between these 2 points. So it seems that this module is a servo control amplifier in order to drive this motor. Okay, so this module is this one. So this is effectively a magnetic amplifier. Therefore, this transformer is probably the saturable reactor. So it can be interesting to do the reverse engineering of this servo control amplifier. That's all for today. Thank you for watching and see you next time. Bye bye.